Brent Okerson's going to talk to us about electrical safety.
So electrical safety. Today we want to look at things that we see regularly as we go around the state and do inspections at facilities. And in looking at buildings, we want to look at several things that can be a hazard to us and talk about what electricity is and some of the hazards and things that have gone on with that we can learn from to protect ourselves. And electricity is one of those things that we're around all the time, every day. They're in our buildings and in our homes and where we work. And so we just want to highlight those things to watch for and raise awareness to how to protect ourselves around that kind of stuff. So what is electricity? It is the flow of electrons, and it seeks ground. Just like lightning seeks ground, so does electrical when it's in a circuit. That's why we have grounding and things in place, and that's why we need to have them set up properly with good protections and good insulations, because we don't want to become part of that path where the electricity goes through us and seeks ground through us. It can be lethal in small doses. We'll look at today some of the different current amperages and voltages and things like that can be detrimental to our health. So we'll look at that. But even in small doses, it can be enough to cause some health effects on us. So we'll watch for that and talk about that today. There's actually an equation for this for electricity, for the voltage. It's the V equals IR, and what it is the voltage is equal to the amount of current and resistance. So that's what we want to look for there is what is the electricity. Are you conductive? That's a question to think about. Are you conductive? Could electricity flow through you? Could you be part of completing an electric circuit? The answer is yes. There's many different conductors and materials in this world that are conductive. Metal is one of those. That's why they use copper in all of our wiring. Copper is a very good conductor. So is water. And you think about our body and what it's made up of. Well, we're made up of a lot of water. And in that water, there's often different traces of minerals and things that are conductive and allows for electricity to flow through us if we're in contact with that and part of an electric circuit there. So there's also insulators, and these are things that protect us from electrical hazard. That's why your wiring has the copper inside, which is the conductive part, but it has a plastic or rubber insulator on the outside that protects it and keeps it contained. So what happens is if you have a break in that, or if it's not fully protected with a good insulator, it can travel elsewhere, and that's where electricity can become a hazard to us. And so we need to think about what kind of things are we using as we're working around electricity and different hazards. If you're working around overhead power lines, it might not be best recommendation to use a metal ladder, because obviously a metal ladder could be conductive, and you could find yourself in a bad situation with that. Think about the tools that we use, the different types of materials that make up the tools, different objects and things that we work around. They could become conductive and could lead to us getting ourselves in a bad situation. So think about where you go. Think about your workplace, your work environment, the types of places you're around electrical hazards, whether that's in an office or a building or a shop or even at home. There's many places we really need to protect ourselves, and that's the goal today, to raise that awareness. There are some shocking realities, unfortunately. In the United States, every year, on average, there's about 30,000 people that get injured from electrical situations where they become in contact with that. About 1,000 people get killed every year as well, losing their life. Maybe they're taking chances or cutting corners, or maybe it's just by not being aware and they accidentally come in contact with that. People lose their life and get injured, and that's something we want to raise awareness to about that. What kind of injuries are there? What do we see with electrical injuries? Electrical shock is one, and there's different, severity and types of that, but we'll talk about that later. There's also burns that can happen, electrocution, arc flash, which is the picture here on the left. Somebody's working at a panel, they get an arc flash, and it explodes out at them. There's explosions, there's potential fires, and thinking about it, with electrical hazards, it could be an injury to yourself, it could be damage to your property or equipment, maybe even causing a fire and burning down a building. So we want to look at these today and learn from them, see how we can prevent that. So looking back over this year in 2018, I'd look back over some claims that we've seen. There's been 3 employees that were affected by electrical hazards and 3 claims from that. One, we had an employee that had an electric shock while fixing an electric door. One had arc flash happen where the employee received second-degree burns on their face, and another arc flash where employees' eyes were burned from working around a transformer. So fortunately, these employees are, they're still with us. They haven't lost their life, but these are all, severe things that could happen, and somebody could lose their life from these types of things. So we want to learn from those as we work around that. So safety is really the critical thing. We talk about this every year and every month on our webinars with the safety moments and loss prevention webinars that we do. And we say this a lot, but safety really is the priority. It really is the number one thing. And with electrical hazards, it's a very high risk thing. It's something that can affect our life and change our life forever. And so we have to respect that. We have to always be aware of the hazards around us and not become complacent, because a lot of times that's what leads to getting ourselves in a bad spot and not paying attention and possibly getting an injury from that. So here's a question: Is greater voltage, does it equal a greater danger? Not necessarily. Sometimes the higher voltage can have more impact and effect and damage on our body if we come in contact with that. But even smaller doses of electric current can be enough to cause an injury. And we'll look at some of those today too. But most of the time, most of us work around 120 volts. That's in our houses, it's in our work offices, it's the outlets in your wall. That's what we're around. But there's greater than one death per day just from working around those types of things. As much as 120 volts is enough to kill somebody if it's not protected and if we find ourselves in the wrong spot. So those are things we have to think about. It's got to be our own safety. We've got to protect ourselves and others and make sure we don't let electrical hazards become a problem there. So talking about the different hazards, you could have a shock, and some of you might have felt a shock before. You know what that feels like when you accidentally come in contact with one of those wires that maybe you thought the breaker at the panel was turned off, and you made a mistake and you're changing an outlet, and you feel that little shock. That happened to me one time. I was changing out an outlet under a sink and thought I'd turned off the right breaker, and I failed to verify before I went and worked on that outlet and changed it out, and I got that shock. And I remember that tingling sensation that you get when your hand comes in contact with that. Those of you that have been shocked know what that feels like, and it's kind of uncomfortable. It startles you, and that can happen with injuries. Sometimes it's that shock itself that can cause the injury, depending on how it passes through you and how it affects your body or the voltage. Sometimes there's an indirect accident or an indirect injury that happens from getting some type of a shock. And for example, there was an employee one time working on a ladder. He was changing out a light over his head and got a little bit of a shock, and that shock didn't do any damage to him, but it startled him enough and caused him to fall off the back of that ladder and get injured from the fall and hitting the ground. So electrical hazards, can affect us in many ways, not just the shock itself, but potential impact or falling on the machinery or something else that could happen. So we have to realize and not have the mindset that it won't happen to us, because it could. It could happen to anybody at any time if we're not paying attention, or if we're being careless, or if we're not correcting things the way that we should. We could accidentally come in contact with something like that, and it could affect our life. And that's the goal of the training today, to raise awareness to that. So how does it affect our body? It depends. If you complete part of a circuit and it passes through your body, it can be a real problem for you. It depends on the current and the voltage. Sometimes the higher, the higher voltage is obviously going to be more intense, but we'll look at some lower voltages too. It depends on the resistance, how much your body is resistant to completing that circuit or passing through, or if there's other materials or clothing or things that may cause a resistance there. It also depends on the path through your body. It's one thing to have a shock and have it pass through your hand or your arm, but what if it passes through the middle of your chest and goes through your heart? What if it passes through your head and your brain? That's going to have a greater impact on your overall health and possibly a worse injury from hitting those vital areas. And it can disrupt the rhythm of your heart. It can change your heartbeat. Can even stop your heart, depending on several things there. The duration of the shock is another. The longer that you're completing that circuit, the longer that you're there connected and it's passing through you, the more damage that would be done to your body too. And so those are things we want to think about. Electric shock, it can cause tissue damage and defibrillation, changing the heartbeat of your heartbeat, and also can lead to death. So there's certain levels of current that you can feel, and where that starts is about 1 milliamp AC or 5 milliamps DC. That's a sensation that you can feel when you know you've been shocked, and you can tell. If anybody's ever touched an electric fence, you know that's kind of a, it's an uncomfortable thing. It startles you, and you can definitely feel that. You know what that shock feels like. Greater than 3 milliamps would be a painful shock. It could lead to an indirect accident where it could startle you and cause you to fall or lose control of your balance. Greater than 10 milliamps could be muscle contraction. That could be where you can't let go, where you grab something and it causes your muscle to lock up and you just can't let go of what you're connected to. There's been situations where people had serious injuries from that, where they couldn't get the person off in time, and their muscles are locked up, and they have severe injury or possibly death from that. Greater than 50 milliamps, this is where you get ventricular fibrillation. This is usually fatal. It's at a level that's very severe. If that passes through your heart, you're obviously going to have some health effects from that. 100 milliamps to 4 amps is fatal, and that's where it's at a level that's really dangerous, where you could have heart paralysis or some severe burns. I've heard of stories where guys become in contact with a line that's at a higher voltage like this, and they can't let go. They're connected to that, and that electricity is seeking ground, and it will pass through them. There's been times I've seen pictures of toes of people's boots that are completely blown off because the electricity seeks ground. It goes down through their leg, comes out the front of their foot, and literally their shoe is blown wide open from the force of the electricity through that. So there's some severe things that can happen if we don't do things the right way. There's some real hazards, and we just want to bring awareness to that today. Of if you're working around those things, make sure you're doing it right. Make sure you're using qualified electricians and doing the installations the right way to protect yourself and the public. So OSHA has regulations on this. The main thing is that all workplaces need to be free from recognized hazards pertaining to electricity that are likely to cause death or serious physical harm to employees. And so what that means is we want to see that everything's covered up, that there aren't panels left open, that there aren't wires hanging out of the wall, that there aren't outlets that are missing cover plates. Things should be covered up with good install, secure, and safe to work around. That's one of the key things to look for. Some of the things we see as we go around, we'll highlight some of these now. One of the main things we see a lot is in the front of electrical panels, there's often a lot of things stacked and stored and blocking access to the panel. It is required that there be at least 3 feet around all the panels that should be open. There shouldn't be anything in the way stacked in front or blocking access. If you think about it, if you had to get to a panel and shut it off real quick, you wouldn't want to have to move things out of the way. You wouldn't want to have to trip over things or take extra time to get to that breaker and turn things off, and that's one of the main reasons why you've got to keep those clear. Some people will mark out on the floor, they'll mark out a 3-foot space around it like you see in the picture here. They'll take some red paint and mark that square around it to remind people that, hey, this needs to be open, it needs to be kept clear with access to the panels. That's the best practice for that. Identification is another thing that's required. When you open up your electric panel, there should be labeling, and you should be able to label on there what each breaker is for. It should be able to withstand the environment that they're in. You should be able to read it and clearly identify whether it's to a shop or a certain room or something there, but it needs to be marked and it needs to be identified clearly. Breakers, they should be the right size. They should be adequate for the type of circuit and current that it's going to carry, the amperages. You don't want to put things in that are the wrong size and not equivalent and not capable of handling the load that's going to be put on the circuit there. And so that's why it's important to use a qualified electrician. They will know how to look at these. They will know how to get the right type of breaker with the right amperage and match those things up for the system that's being installed. You don't want to take chances on putting something in and having it be the wrong kind. Grounding is another issue. Like I said, electricity is always seeking ground. And here we have a picture of a pole that had a grounding wire on it, and somebody had come along and cut the copper grounding wire, and so it was an incomplete grounding. It didn't complete all the way to the ground. So the path to ground from circuits and equipment and enclosures must be permanent and continuous. This is something that you want to check for. Make sure that copper isn't missing, or that the ground line is not connected. One of the key things is to always inspect. Here we have a picture of a ground pin that's missing from a portable tool, and this happens a lot. Sometimes people on a job site will go to plug in their tool, and it will only have two connectors for the outlet there, and so they'll pull that ground pin off and modify the equipment. And what that does is it removes the grounding. It puts yourself in danger if electricity were to get out and need to go somewhere else, and there's no proper grounding. You could become part of that circuit and possibly be electrocuted from that. And so it's just not worth taking that risk. The key is always inspect your equipment. Look at things, make sure that grounding is in place, make sure that there's no modifications on tools, that they're grounded and protected properly. We also see overloading with electrical outlets. So here we have some splitters that have been put on the outlet, and also a whole bunch of other extension cords that are splitting off and overloading the circuit. And this is a real hazard. The reminder here is that extension cords are a temporary, they're for temporary use. They're not a permanent wiring for a machine or something that you have plugged in. They're only for temporary use, and they're something that just can't be overloaded. So make sure you're not plugging in too many things and splitting things off too much to where it overloads that circuit and can cause something to trip or cause a hazard there. Here we have a picture of a wire running through a wall. This is a case where somebody had a machine or some type of equipment plugged in for a long time, and they were using it as a permanent electrical connection. And again, extension cords, they're not to be used for a permanent setup. If you need to have a machine that's constantly plugged in, you need to get a qualified electrician in there and get a new outlet put in to have a dedicated circuit for that equipment that you have. So they shouldn't run through holes or anything in the wall or through the ceiling or even around a room. They should be, you would want an outlet in that situation and not just use an extension cord. When you open up your panel, this would be a real hazard to open this up and see things that aren't covered up, and see a possibility where your fingers could get in and get an electrocution with exposed wires. Again, there needs to be proper covers and things put in place to protect that. Outlets, this can happen sometimes if an outlet is damaged or maybe you're replacing one. This is something that you don't want to just leave hanging out there where someone could come along and put their finger in there and come in contact with the wire and get electrocuted. All outlets need to be secured and in place. They should have a cover and a plate on them, covering them up, making sure that things are sealed properly. That goes for all of your outlets and switches and light boxes and things like that. You want to have those things covered up and fully secured. Look at your wet areas. So here we have a kitchen sink, and we have an outlet right next to it. So there's actually a building code that requires within 2 feet of every wet area there needs to be GFCI outlets, which is a ground fault circuit interrupter. What that does, if water were to splash into that outlet or if it were to get wet in some way, it will cause that to trip the breaker, and it immediately shuts it off so that there's not a continuous circuit and that you don't become part of that. So what happens is there's a 3 milliamp difference. If that circuit senses any difference in 3 milliamps or more, it immediately shuts off and closes that circuit so that you don't become part of that. So those do need to be in your wet areas. Make sure you check those out. Also, on the note of GFCIs, if you're on a job site and you're working outside, or maybe there's some rain or electrical tools that you're using outside, it's a good idea to use a GFCI. They have some portable ones that you can plug into generators or on the outside of a building, and it can help you to prevent that, so that you don't have a wet situation where you could become electrocuted. This is something that we see a lot. I see these at parks and on the outsides of buildings all the time in public places. These are where you have those weatherproof covers and the little flaps and bubbles and things. They can get broken off easily, and a lot of people play with them and snap them back and break them off. This is a constant thing you want to look for and make sure that your outlets are protected from the weather and the moisture and things outside. But the constant thing that you'll need to check and replace is these covers. You want to make sure they're fully covered. Take a look at your tools. Make sure that your tools are in good condition. The picture here, you can see the cord on this has been strained, and the insulation is being pulled back. You don't want to pick up a tool and plug it in and find out the hard way if something's not protected right, if there's not good insulation on it, or if there's something exposed. So always do a good inspection on it first. Use the right tool. Check that ground prong on that plug-in area to make sure that it's there. Some tools will only have 2 plugs on them, and that's because some are a double insulated tool. And what that means is that tool is designated as being intrinsically safe, meaning that it's all contained within the tool itself, and there's no need for that ground prong. And so if that's the case, look at your tool. There will be some markings on there that will say whether it's double insulated. It will just have that lettering on there, or it might have a little symbol on there which is a square within a larger square. And that's just telling you that this tool is double insulated and protected and doesn't need that grounding prong at the plug-in. But inspect for damage. Make sure you're using good tools in good condition and maintaining those. Use them in a dry work area, and like I say, if you are working outside where there could be moisture or possible water, definitely use a GFCI, a portable GFCI plug-in for those. The key is, we have to inspect. We have to look around, look for things, because things get damaged, things get broken really easily. Sometimes you might have something in progress of being repaired, and you might have some wires hanging out, or an outlet loose, or a cover plate missing. If you do see something like that, take some action on it and, fix it. Tell somebody, make sure that it gets corrected, that it's not left out for somebody to come along and get hurt. This picture here reminds me of something that I see at parks in public areas sometimes. This is a light pole, and at the base of it, just inside of that is where they make that electrical connection to the light pole. And so here we have the cover missing, and you can see the wires inside of there. If this is left open, you can have anybody come along, even a little kid, put their hands in there and come in contact with some voltage. And it's a real hazard to the public, and especially children. I've seen a lot of these covers missing sometimes. Sometimes they're still hanging there, they're loose, or just kind of laying on the ground next to it. It's important to inspect all of our facilities and public areas and make sure that they're covered up, because we don't want to have risk or liability, or have a serious injury or accident from something like that because of our carelessness or just not paying attention. And so it's important we always inspect and take care of those things in the places that we work. The key is respect electricity. We talked about the hazards with that, how people get shocked and have some real injuries and damage to their body from that. We've got to pay attention. We've got to recognize those hazards. If there is something out there, it's really on us to inspect and identify and correct those things. And again, the key is protect yourself and protect others. It's not worth taking those chances. It's not worth having an injury or losing a life over something simple that's not put in properly or not cared for properly. So think about what's most important. It really is our safety and our life and our health. That really is the most important thing. We've got to keep that at the forefront at all times. So with that, that's the presentation. Jason, do you have any questions today?
I haven't had any questions come in yet, folks. If you've got a question, type that into the chat box or the Q&A box, and Brent will answer those now. Brent's done a real good job of giving us a reminder on electrical safety and how important that is. We don't think about that animal that's in the wires and in the walls in our buildings and around, but that's really a serious thing that could burn our buildings down or even kill us. So I was just looking at the news this morning. My neighborhood this last week had the power out due to a truck delivering some grain that had an elevator, an auger that came out of it, and they forgot to put it down, and they ran into some power lines, and it put out all the neighborhood, multiple cities around, and that just from a simple thing that somebody forgot to do. Luckily, nobody was injured in this event, but it certainly had an impact on my community. So All right, I don't see any questions coming in. You must have really covered it well, Brent.
All right.
What's the final word?
Be safe out there. Everyone have a great day and stay safe.
Okay, I have to turn my camera around. Oh, maybe you can't see.
It's a little snowy out there.
It is dumping snow right now, folks. Be safe out there. That might just be a Davis County thing. A little bit of lake effect snow, but anyway, be safe out there, and let's have a good, safe remainder of this year going into next year. Have a safe day.